Okay, question number 28. The diagram shows the shape at one instant in time of the part of a stretched wave as a wave travels along it from left to right. So, this is a wave which is traveling like this, and there are 3 points shown in the wave. Okay. What are the directions of the velocities of the points 1, 2 and 3 on the string at this instant in time? Okay, you need to find out what are the velocities of 1, 2 and 3. So, what we will do is we will take the starting point, and from here we will, okay, let me start the timer. Okay. So, let us draw a line here, which is nothing but your baseline. When I draw the baseline over here, I observe that this positive half is equal to negative half, symmetrically equal. So, it is a proper wave. Okay. Now, you see the points 1, 2 and 3 are at the same positions, and you can also observe that the point 1 and point 3 have the same behavior. See, if there is a particle here, and if this is vibrating like this, this is also vibrating like this, while this particle is now trying to come downward like this, which means the velocity of this particle and velocity of this particle should be the same. Okay, we should be in the same direction, while the two should be in the opposite direction of these two particles. Now, see, there are several arrows being shown. Okay, so there are sidewise arrows, there are also upward and downward arrows over here. Now, let us look at which of these arrows will form into that pattern, which means what? If this is up, this should also be up, this should be down. If this is side, this should also be this side, this should be left like this. Okay, something like this should be seen. So, towards which of them will fall? Now, let us look at the first point. Point 1, 2 and 3 are in the same direction. So, definitely no. This is not the right answer. Now, 1, 2, this is opposite. So, this could be one of them. 1, 2 same, 3, this is opposite. So, this also could be an answer. This also could be an answer. So, it's not very clear about the pattern. Now, let us understand something here. Now, you see, when the particle is vibrating like this and it comes to this position, what will be the velocity of this point? The velocity of this point is 0 here. That means as we go like this, every particle as it is going nearby to this point, the equilibrium point, you observe the velocity keeps on reducing. That means here the point 1 and 3, velocities are reducing. Now what about here? Now as the particle comes downwards here, when it reaches this point, what happens to this point? The velocity will increase, right? So therefore, point 2, the velocity is v is increasing, and here the speed is decreasing over here. Here also speed is decreasing. So which will correspond to this pattern? So definitely this is not the case. This is also not the one. So answer D. D is downward, downward, upward, downward, downward, upward. So this is the right answer. Answer D is the right option.